Assalamualaikum. Today, my group will do a group assignment for Technical Mathematics 2, DAS11103. Okay, so this is our team members and our instructor is Dr. Muhammad Zalarifin. Okay, so first one, we see the question 1. Assume that oil spilled from a ruptured tanker spreads in circular pattern, given that the radius r in m of the spilled oil is increasing at a constant rate of 2 ms. So the first question is obtain the area A in meter square of the circle and hence find the dA over dr. 2 marks. Okay, so first one we see the answer. The area of A of a circle is given by A equal to pi r squared. To find dA over dr, we differentiate A with respect to r. So when we differentiate dA over dr, we get the d over dr pi r squared equal to 2 pi r. So that's the answer. So next one, I will explain about question 2. Use question 1i to calculate the rate of change of the area dA over dt when the radius is 40 meter. Okay, so 3 marks. So first one, we should know that we are given that the radius r is increasing at a constant rate of 2 meter per second. Okay, so the dr over dt is 2 ms. Like we see in the ni, is increasing at a constant rate of 2 ms. So this one is dr over dt. So we need to find dA over dt when r is 40. Okay, in this state that radius is 40 m. Using the chain rule, we have dA over dt equals to dA over dr times with dr over dt. So the r is 40 m. From part 1, we know that dA over dr is 2 pi r. This one, dA over dr is 2 pi r. So we need to substitute r 40 m and dr over dt 2 ms into the equation of dA over dt 2 pi times 40 times 2 dA over dt equals to 160 pi. Therefore, the rate of change of the area when radius is 40 m is dA over dt equal to 160 pi meter squared per second. So this one is the answer of this question.
Okay, so then we move to the next question, that is question 3. The question is the drop in voltage or V in millivolt when current is passing through a circuit is given by. This is our equation. V in bracket T equals to T to the power of 3 minus 9T to the power of square plus 24T, where T is time in seconds and 0 is less or equal to T and T is less or equal to 6. Use first derivative test to find the absolute maximum value of the drop in the voltage in that time interval. Okay, so first of all, this is how our group solve this equation. First, we differentiate them by using dV over dt. That's equal to 3t power of 2 minus 18t and plus 24. So we get the critical point dV dt equal to 0. Then we convert this equation into what we call quadratic equation. So we get 3t to the power of 2 minus 18t plus 24 equal to 0. So t in this equation represent x as a quadratic equation. Ax squared minus x and plus c, or it can be plus x or plus minus. So we get the final x or t is t equal to 4 and 2 equal to 2. So there's a 4 outcome. First we get the final one, 0. We get the outcome from this equation. T equal to 4 and 2 equal to 2. T equal to 2 and the maximum point is T equal to 6. So then we put in the main equation, we put over there and we get 4 answer, 0, 20, 16 and 26. So the absolute maximum value of the drop in the voltage 0, less or equal to 8 and less or equal to 6, time interval is 36, and this is how we solve our problem. Okay, thank you.
For question 2 is to be cleared of sediments using a cone-shaped filter. Given that the height h of the cone is 16 cm and the radius r at the base of the cone is 4 cm, if the liquid is flowing out of the cone at the rate of 2 cm cube per minute, find the rate of the liquid level dH over dt is decreasing when the level is 8 cm. From the question, we know that the height of the cone is 16 cm and the radius is 4 cm. From this and from the question we also know that the dV over dt is 2 cm cube per minute, and we need to find the dH over dt when the h is 8 cm. First we need to find the volume of cone. Formula for volume is 1 over 3 times with pi times r square times h, and from the formula we can secondly we need to find ratio of the cone. So r over h equals to 4 over 16 equals to 1 over 4. So the ratio for radius to height is 1 over 4. And from this we can know that r equals to h over 4. So we continue with the solution. Firstly, we insert the r h over 4 into the volume of a formula of volume, where we get V equals to 1 over 3 pi times h over 4 square times h. And from this we get the answer 1 over 48 times pi h cube. So we can continue with finding dV over dt. dV over dt equals to 1 over 48 pi times with 3h square times dH over dt. So we can simplify it into 1 over 16 pi over 16 h2 dH over dt. So dV over dt is equal to 2 and the h is 8. We insert this into the formula. So 2 equals to pi over 16 times with 8 square dH over dt. We can simplify it, and lastly we can find that dH over dt equals to 1 over 2 pi. Thus, when the height is 8 centimeters, the rate of liquid flowing out is 1 over 2 pi.